All right, scientists, it's been a while since I've done a video to help explain a lesson. I probably should do it more often. But this one occurred to me because I feel like a lot of you um, might do this wrong, which is fine. Tomorrow we will obviously go over this, and if there's any things that need clarification, we can fix it. But um, I think that this skill of using this soil triangle can be confusing, and certainly until you've practiced it more, you might get some of these wrong. So I kind of want to go through the process like I showed you today, and just kind of repeating things may or may not help some of you. What I will say is that if you are looking at your homework, the front page or the first page is basically a typed explanation of how to follow those steps to use the soil triangle. So reading it very carefully, following those steps might be helpful, but this video may be helpful for those of us who are more visual. So anyway, we'll just pick one of these to do. And actually, I'll do D because D is a pesky one for a couple reasons, and I kind of maybe it'll be a good one to show that. Um, but but ultimately, what we're doing is we're basically saying if I have a clay sample, or I'm sorry, if I have a soil sample, um, that's 100% of my sample. So if I'm saying that soil sample has some percent of clay, some percent of silt, some percent of sand, then together those three parts should add up to 100%. So one thing you should know if you were listening in class is that basically the three numbers added together have to equal 100. So one thing you can do is use that to your advantage. So if we're looking at D here, problem D, we know that there's 52% silt and 27% clay. Now, if you add those together, you get 79. So again, 52 plus the calculator over here, plus, what was it, 27, that gives you 79. So if you know that all of it together, the three parts, is 100, you could just basically take 100 and subtract 79 from it, and that leaves you with 21, right? So you know that this answer right here for D must be 21. Now that means that it's 21% sand, 52% silt, and 27% clay. Now that doesn't tell you what type of soil it is or what the texture name is. So that's where you have to learn to use the soil triangle properly. Now in class today, in the time that I gave you to work on this in class, some of you were making mistakes that I was trying to correct. And the most common mistake is that when you're drawing your lines to look for the intersection, you're not following these parallels, right? So just like in map reading with longitude and latitude, you got to follow these lines at the angles, the parallel angles. So one thing that could be confusing that may help, and if I could do these sheets over again, I would probably do this. I would draw an arrow, and I'll use a big arrow here. I think this will work. The silt lines all are going to run down at this angle. So if I draw an arrow right here, I'm going to have to flip it, but that's all right. So silt lines will go this way, down at this angle, and I'll even try to fix that angle a little more. I think it's more like that. So the silt lines are going to run down this way. The sand lines are going to run at the diagonal up this way. So again, I'll duplicate this. And the sand lines are going to run at the diagonal going upward that way. Now, what's really important is that you don't just go up, but you actually follow this line at that angle, so parallel to these lines that are running this way. Okay, and then the clay one is a little easier. The clay is running what I would consider straight across. So that one is a little easier to do because you're just following the lines straight across. None of them are hard. It's just that you just got to make sure you're following these guidelines. Now, now let's get to the work, right? So we know it's 52% silt. So we come to the silt side, the side on the right-hand side, and we find 50 and we find 60. So it's somewhere in between those, and the one in between is 55. So you gotta basically, just like all things scientific, you want to be as precise as you can. And this isn't an area where it has to be perfect, but you just want to try to find where you think 52 would be. So you put your pencil there, and I'm going to draw a line using my Google Slides here. But 52 would be somewhere about right there, I think. So I'm drawing my line right there. Now, it's not important that you draw the line for me. I'm not going to be grading your lines, but it might be helpful for you to use a straight edge, or um, whatever pencils, and just trying to make that line or knowing where it is. It's right there. I'm going to color it red so it stands out a bit. So that's my line that represents 52% silt, because that's the number right there. And then my 27% clay, I'm going to come on the left-hand side over here, and I'm going to find where 27% would be. 20 is here, 30 is here, so 25 is in between. 27 is right above that. So just like I did with the silt, I'm going to take my line, and I'm going to find where I think 27 would be. I'm just going to go slightly above the 25 there and draw my line, trying to make it as straight as I can. And again, hopefully you understand what I mean by the parallels, because you should know what parallel means. But that's where my parallel line is. Make it red. So you can kind of see that that's parallel with these lines that are running across straight like this, whereas the silt is running on a parallel at a diagonal with these lines. So this can look really confusing, but once you get the hang of it, it isn't that hard. It's just a matter of learning a little bit about how to do it. Now, right there with those two lines, I know that those intersect right there. So I'm going to call this silt loam. So that's what you type here. That's the type of soil it is. The texture is a silt loam texture. That's what you type in this, or you write. If you're doing the paper version, you write silt loam right there. Now, interestingly, right, we know the answer to this is 21, right? Because we did the math. We did 52 plus 27 and then subtracted that from 100, and we got 21. Now, this is where things kind of get, this is where this method of figuring out the third number isn't always assured, because if you use the graph or the intersection line, you might think the intersection's right there. And if you were to draw a line, or I should say, if I was to do this, I might guess, if I was just using the intersection, I'm going to move that a little bit, but yeah, intersection right about there. Now, if I was to, that's where the intersection is. If I was to follow that down to where the sand is, I don't think I would call that 21. I might call that 22, 23 maybe. Now, I know the answer is 21, and that's why you can't count on the line drawing method to figure out the exact answer. It'll give you an approximation, but it won't give you the exact answer. So kind of the combination of the two is best. Obviously, knowing the math that the three numbers have to equal 100 is obviously the easiest, fastest, most accurate way to get the precise number, but that doesn't give you the type of soil. Now, the two numbers alone will give you the type of soil. In this case, I'm calling it silty loam, okay? And that's my answer. So hopefully that makes sense. And again, fill these out, do the best you can, bring it in tomorrow. Many of you already turned it in, but we'll go over those and check those tomorrow. But that hopefully helps. And I'll see you guys tomorrow. Have a good night, scientists.